All right, good morning, ladies and gentlemen. Here we are, Science 10, and today we're going to do some work. Yeah, you got some to do. Actually, we're dealing with work, and work has of course, a scientific or denotation to it. There is a special definition of work, and we're going to get to there. But first, let's talk about forces. Now, a force uh, is a push or a pull. And so if you pull your sister's hair or push your brother down the stairs, don't do that. Um, that you're exerting a force on them. And we know that the units of force is the Newton, and we use a capital N as reference to that Newton. We took a look, well, I'm not sure that we actually talked about types of forces. Uh, We might have. I can't remember. Doesn't really matter. But there are. It doesn't really matter. There are certain types of forces. We have uh, gravity, gravitational force. That is definitely a force that we need to talk about or work with. We have spring forces, and I don't think we'll be doing anything with spring forces, but just recognizing that they're there. And we can store energy, we can store forces within the springs. We also have the strong nuclear force. Now, the strong nuclear force happens only in the nucleus of the atom. And it's where you have all these positive protons that are being held together in a very small package. And the strong nuclear force is responsible for keeping those together because the positives want to repel the positive. They want to get away from each other. And this is really, really tiny in relation to the size of an atom. If you remember, just as a bit of a connotation, if an atom was the size of our gym, then the nucleus would be like the size of a fly. And that's approximately a good comparison for that. So the nucleus is extremely small, so we have a very strong nuclear force that is responsible for keeping it together. There's also what's called a weak nuclear force, and the weak nuclear force is responsible for radioactive decay and for sending out things such as hydrogen or helium nuclei, alpha particles come flying out, and it's due to what we call the weak nuclear force. And then we have electromagnetic forces, and that's really like the positives and negatives in here. And when we have moving charges, then we have magnetic forces that come about. So electromagnetic are really two forms of the same type of force. So if we're talking about forces, these are really there. And the spring forces would really be more of an electromagnetic force in interaction between the atoms that are within the material. So we have gravity, strong nuclear force, weak nuclear force, electromagnetic, and then when you push your brother or sister. So those are the types of forces. No. So what we saw the other day, last week, was the dealing with gravity, and just to remind you of that. And what we did was to set up a triangle, and the triangle said that the force of gravity is equal to our mass times a gravitational field strength. So if we had something where the mass was, say, 3 kilograms, and we wanted to know what the force of gravity was, then we could say F is equal to mg. That is our formula. We're looking for Fg, so it's like covering this up. So that's our mass times our g. And so that's going to be 3.0 kilograms times, well, g. And g is a constant that's equal to 9.8 newtons per kilogram. So 3 times 9.8 then gives us a value of 29.4 newtons. So the force of gravity acting on this 3 kilogram object is equal to 29.4 newtons. And this is what we call the weight. The weight is not the mass. Weight is the force of gravity acting on a mass. Mass is a property of the matter. All right, just to remind you, but we have the idea of this triangle that helps us out. Well, work now has, as I say, it has a particular definition, and work is when a force does something. And what it's doing is that it's moving a distance. Now, you're going to find that in some places the word that's used is displacement. Now, that's just a particular word, but distance and displacement are the same thing. They both start with D. You can work with it. And this is the equation that we use. W is equal to FD. And so, while we had FG is equal to MG, and we used a triangle, and we had our FG, MG, let's use a circle. And we're going to do the same thing. But here our work is equal to our force times our distance. W is equal to FD. And so what's single by itself is on top, and what's multiplied together is on the bottom. And what this does is that it allows us to, without using algebra, know the different forms of this. So M would be FG over G, or G would be FG over M. Likewise down here, work is force times distance, work is force times distance. If we wanted to know the force, well, we'd cover this one up, and then we have work divided by distance. Or if we wanted to know the distance, we'd cover this one up, and it's going to be work divided by force. So this is one equation, three forms. Likewise, this is one equation and three forms. All right? Triangle, circle. You can do any shape you want, but that's just work. All right, so we can say how much work is done when a 75 Newton force pushes a box 3 meters. Well, we have this work, force, distance. Work is equal to our force times our distance. So how much work is done? We have 75 newtons. Well, what is 75 newtons? Newtons, well, that's a force. It's pushed 3 meters. 3 meters, what is that? Well, that's the distance or displacement. And the question is how much work? So this is our equation. This is the format. And so our work then is equal to our force, 75 meters, times the distance, 75 newtons, times the distance, which is 3 meters. And we just then could use our Casio FX260 solar, and our work then is equal to 225. Well, what? Well, here we have Newton times meters, so these are Newton meters. But I'll tell you this, there's an or here, and the or is that this is also can be joules. And joules is the unit of energy. So this is a key thing here because we're going on to what we call the conservation of energy. So we're seeing a progression of force to work, and then we're going on to energy. And this is the direction that we're going. Anyways, how much work is done? 225 Newton meters, 225 joules of work is done. Here's another example. How far did a 25 Newton force drag a wagon doing 247 Newton meters of work? All right, so let's write down our values. We have 25 newtons. Well, that's our force. This is an N. Then we have 247 Newton meters. Well, that's equal to our work. And what's the question? How far? So distance is what we're looking for. Let's write this out. W, F, D. We're looking for distance. We're going to cover up our D. So D is equal to our work divided by our force. All right, so D, we'll take our work. Our work was 247 newtons, meters. What was our force? Well, our force was 25 newtons. And so then we go 247 divided by 25. And our distance is equal to 9.9 or 9.88 meters, so 9.9 meters. That's the distance that we moved it. Just a reminder, I want to see this, I want to see this, I want to see this, and I want to see this, and put lines underneath it or put a box around it. Do something so the answer shows up. All right, another question, another example. 575 joules of work was done lifting a box 4 meters. What was the force involved? All right, we have 575 joules. Well, what is joules? Energy, work. I thought work was Newton meters. Oh yeah, Newton meters and joules are the same thing. We can use them interchangeably. Then we have this 4 meters. Well, what do we measure in meters? Oh, distance. That's what we do. What was the force involved? Force. That's what we're looking for. All right. There we have our information. All right. So we have this work is equal to force times distance. We're looking for a force, so that's covering that up. So our force will be equal to our work divided by our distance. Well, our work is 575 joules. Our distance was 4 meters. 575 divided by 4, that's equal to, just say 144 newtons. That is how much force was involved when we're doing that. All right, let's go through another example. Oh, nope, not examples. We've gone through 3 examples. 3 examples. First of all, calculating work. Then we said calculate the distance given the work and the force. And then calculate the force given the work and the distance. We have 3 variables, 3 types of questions. Use the circle to help you know how to do the calculation. All right, so the other day I went out in our truck and came back home and put down the tailgate and I had a bag of groceries. Now the weight of that bag of groceries, now I gotta find my notes here. The weight of that bag of groceries was 25 newtons. And I came out and I grabbed that bag of groceries and just slid it off the tailgate. I then walked 5 meters and then went up a set of stairs that was 1 meter high and then walked 3 meters into the house where, oh yeah, this was 1 meter here and this was 1 meter here, and where I slid the bag of groceries onto the countertop. Okay, so traveled 5 meters, went up 1 meter, and we can say this is, I'm not trying to put in any strange things here. We traveled 5 meters, went up 1 meter, traveled another 3 meters, and placed it on. So this is 1 meter high, came across this way, and slid it on. How much work? All right. So work, well, we have this 25 newtons. What does 25 newtons represent? Well, it's newtons, so that's a force. Okay. Then we have a distance of all 5 and 1 and 3. So we've got like 5, 6, 7, 8, 9 meters, and that being our distance. And what we're, well, how much work was done? And so we would say, well, here's this, work, force, distance. Work is equal to force times distance. Well, that'd be 25 times 9. And 25 times 9 is a big number, 225 joules. And this would be wrong. All wrong. And here, this is where the subtlety comes in. And this is why I drew this out. If we were to change, so here the thing is that If you consider the bag of groceries, what's the direction I'm moving? Well, the direction I'm moving is horizontally. I'm just taking it in. What's the direction of the force? Well, we got the force of gravity going down, and so I'm having to hold it up with a force. So there's my force, there's my distance. What's going on here? Well, when we talk about work being force times distance, the force and the distance must be along the same direction. So what that means, coming back to this scenario, my force is going up. When do I move up? Well, the only place I'm moving up is here. So this is the distance that I moved upwards in the same direction of the force. Otherwise, my movement was horizontal and I didn't lift up the bag, I just dragged it off and then I slid it on here. So the force in this case is the distance is not going to be 9 meters, it's going to be just 1 meter. And so my work, which is force times distance, will equal 25 newtons times my 1 meter, and that's equal to 25 newton meters or 25 joules. So that's how much work I did in this case. So the subtlety is that they have to be along the same direction. So you need to be careful of that. All right, force and distance are along the same direction. I even gave you a moral to the story. A nice picture with a moral. How great is that? All right, so this then brings us into a different situation because now what we're going to do is that we're going to start putting force of gravity into our work equations. Well, what? All right, so let's deal with this question. How much work is done lifting an 11 kilogram box 1.5 meters? So we have one of our numbers is 11 kilograms, right? There it is. Well, what do we measure in kilograms? We measure mass. Mass is in kilograms. And then we have this 1.5 meters. Well, 1.5 meters, what is that? Well, that's a distance. Well, the question is how much work? Well, we know work, force, distance. Work is equal to our force times our distance. And that the force and distance have to be the same direction, our force and distance, or our force and our distance. They'll have to be along the same direction. So how much work is lifting an 11 kilogram box? Okay, well, 1.5, so work is equal to our force times our 1.5 meters. We got our distance. How much force is involved? Well, this is where how much force, what are we working against? What are we doing? We're lifting it. So that's a force of gravity that we're having to put in. And so we have F is equal to mg. So we need to find this force of gravity so we can put that in to this over here. So our mass is 11 kilograms. Well, G, what's G? Oh, yeah, right, 9.8. This is our gravitational field strength, newtons per kilogram. And so we go 11 times our 9.8. I can use round numbers. And we get 108 newtons. So I'm going to put 107.8, so I just use 108. 108 into here times my 1.5, and so that gets me 162 Newton meters of work. That's how much work was having to be done. So here we're having to use both of these equations, our work and our force of gravity, because we're given information in terms of mass. Let's go to another one. 550 joules of work was done lifting a box 3.2 meters. What is the weight of the box? What is the mass of the box? Isn't this the same thing? Weight and mass? No, sir. Weight is in newtons, mass is in kilograms. Oh, right. Thank you. All right. So we have our two equations, and let's write them out this way. We have F G, mg, and then we have our work is work, W, not F. Work is equal to force times distance. So yeah, we can summarize in this way. So what do we know? Well, we know we have 550 joules. That's our work. Oh, okay. 3.2 meters. Well, what's that? What do we measure meters? Distance, displacement. There's a 3.2 meters. We want to know what the weight is. Weight is our force. Can we do this? Sure, we've got this here. With force, it's like covering this up. So our force, our weight is going to be our work divided by our distance. Our work, 550 joules. There's the work. What's our distance? 3.2 meters. So the force, 550 divided by 3.2, that's 172 newtons. And this represents the weight. That's the force of gravity that's acting on the object. Well, the second part of this is asking for the mass. Well, if we want mass, there's our mass. So our mass is equal to our force of gravity divided by G. What's our force of gravity? Well, that's our weight. So we have 172 newtons, and G is equal to 9.8 newtons per kilogram. So we go 172 divided by 9.8, and that's equal to 17.6 kilograms. And there we've got it. There's our mass. There's our weight. There's our mass. Kilograms, newtons. A 4-kilogram bag was lifted with 375 newton meters of work. How high was it raised? All right, so here's 4 kilograms. So we write down 4 kilograms. Well, what do we measure in kilograms? Well, that's the mass. All right. Was lifted 375 newton meters. 375 newton meters. Well, what do we measure in newton meters? Work. Oh, right, work. And then the question is, how high was it raised? So the height or distance is what we're looking for. Okay. Well, we're dealing with work and distance, so we have the idea that work, force, and distance. And we're looking for the distance, so distance is equal to our work divided by our force. And so our work is 375 newton meters, and our force, we don't have a force. Well, what are we doing? It's raised, was lifted. So that means we're dealing with the force of gravity. So let's put down our triangle, and our force of gravity is equal to mg. All right, so we need our force, and so this is what we're looking for. So our force of gravity is equal to mg. Our mass, well, we said our mass was 4 kilograms. 4.0 kilograms. Our G, that's our constant, 9.8 newtons per kilogram. So 4 times 9.8, and that's equal to 39.2 newtons. That represents the force of gravity. That represents the force that we would have to put into this. So we can go then 375 divided by our 39.2, and what we get is a 9.6. 9.6 what? Well, what were we looking for? We were looking for the distance. And so this was raised 9.6 meters. That's how far we had to raise it. So you can see that, we can have questions that deal just with work or just with force of gravity, or we can deal with questions that deal with both of them. And they're not hard. You just follow the pattern. Look for the information that you're given. Okay? So, homework. I'm going to attach a worksheet. I'd like you to do questions 1 to 8. It's just a 1-page worksheet. It's going to be filling in some things and summarizing. But just, I'm going to write these down again. The force of gravity is equal to mg. And we've got work is equal to our force times the distance. F equals mg, work is equal to force times distance. Now, this is where, if you go into physics 11, you need to be aware of algebra and how to work with this. Use these equations. These are helpful as it just gets through, and you don't have to worry about the algebra. So the choice is yours. They're there. All right, that's it. I got to get this out and uploaded, and I hope you have a great day. Take care.